So many of these decisions that we're talking about influence vehicle design, what cities we want to launch, where we want to build infrastructure, how we're going to price the service, how their back-end algorithms are going to actually serve to operate this as a mode of transportation. So this is really important to us. And so we've gone really deep with, I think, virtually every provider out there. And so it's actually a very non-trivial problem. And I think there's a couple interesting opportunities for disruption, to be honest.
Welcome to the next edition of the Decision Intelligence Lab podcast. I'm your co-host, Vijay Mehrotra, and along with my co-host, Michael Watson, we are thrilled to introduce Jon Petersen, our guest today. Jon's the vice president of data at Archer, which is an aerospace company, developing an electric vertical takeoff and landing aircraft that's aimed at revolutionizing urban mobility. As somebody who lives in a congested urban area, I am rooting for them. Jon leads Archer's data science initiative, and prior to Archer, he's held positions in data science and OR at companies like GE Aviation, Uber Elevate, and Sabre Airline Solutions. Jon's got a PhD in industrial and systems engineering from Georgia Tech, and he is the second Golden Gopher that we've had on this podcast, as he did his undergraduate degree at the University of Minnesota. Jon, welcome to the podcast.
Great to be here, Vijay. Thank you so much for having me.
Okay. Can so I'm fascinated, not having an aerospace background at all. Can you give us a brief overview of Archer's mission and what your role and your team's role is at Archer?
Yeah, I'm happy to. So virtually every large city around the world is facing a problem of congestion, where the two-dimensional grid has just not kept up with increasing degrees of urbanization around the world. It's about roughly half of the world's population today lives in urban environments. The UN says that's going to be close to 2/3 by 2040. That's going to exacerbate an already obvious problem with transportation today on the ground. What we're doing at Archer is we're trying to revolutionize urban mobility by deploying that third dimension that's been long sought after. So Archer is designing, building, and then eventually operating a new type of aircraft called electric vertical and takeoff and landing, commonly known as EVTOL. We're hoping that a new moniker will eventually stick, but these aircraft are all electric. They are significantly quieter, and they have no redundancy. So they offer a lot of advantages of other types of rotorcraft like helicopters. We want to use them in an Uber-like manner where people can press a button and get a flight on demand, saving considerable amount of time from door to door in their transportation journey.
Can you elaborate on, I was fascinated by the noise. How important is the noise reduction? Because when I had a chance to be in Norway, and I got on one of their ferries that were electric, and it was such a pleasant experience being on a ferry that didn't have those large diesel engines. So how much is noise important to your all's mission?
Noise is existential to our mission. In fact, one of the reasons that we believe that helicopters have a limited capacity today is they cannot necessarily operate in dense urban environments with the frequency that the public demands. And that is because community groups, rightfully so in many instances, do not necessarily there's a lot of NIMBYs. They don't want these helicopters that are extremely noisy. I think the tip of a helicopter operates something at 800 feet a second. So what our types of aircraft are trying to do is they're trying to reduce that velocity, going from 800 to maybe something just a little more than half. And the noise is proportional to the fifth power of the velocity of the tip speed of those rotors. So when you can reduce that, you have a much quieter aircraft. So that's number one. Number two is, also, the type of noise is very different as well. So helicopters emit a broadband noise, which gives it that kind of wop, wop, wop sound. I'm sorry, That's a tonal noise. My mistake. And what the type of noise that's emitted from our rotorcraft is what's called a broadband noise, which is actually perceived much more favorably from the human ear. So that's a second advantage. So we believe that the noise advantage of these aircraft is such that if we operate them in cities that are already fairly loud, by the way, that the net impact of the kind of ambient noise level is going to be very marginal at best. So that's a really exciting characteristic that, thank you for asking that, Mike. That's I think a question that we love getting.
Jon, you already went up to the fifth power, and we haven't even started talking about data science. Talk to us about your role and kind of what is data science at Archer, and how did it get started, and where has it gone over time?
Sure. So the data team at Archer is a pretty small team. We're centralized. So we support virtually every single team in some capacity. So there's some really fun applications to dig into here in a second. So initially, when we got started, I had the great pleasure of working very closely with our chief engineer, Stanford alumnus Jeff Bauer. And Jeff and his colleagues were responsible for kind of the design of the aircraft. Now, there are thousands and thousands of decisions about the architecture and so the supply base and components on the aircraft, the overwhelming majority of which I'm not certainly qualified to speak about. But three of the most salient questions are the speed, range, and payload of this aircraft. And Archer wanted to do something that I think was fairly novel, that not a lot of, you might be surprised to hear this, but there's something like 1,000 different vehicle concepts that's tracked by the Vertical Flight Society. The overwhelming majority start with the aircraft and try to shoehorn it into a market. There's a very small number of firms that are taking kind of the opposite approach. They're trying to really rigorously understand mobility patterns on the ground and trying to design an aircraft around it to maximize the use in and around urban centers. And so I partnered very closely with our engineering team. We have run, I don't know, hundreds of thousands of simulations of different vehicle concepts in different cities with different assumptions, different wind profiles, and things like that. And that has culminated in a data point that has strongly influenced the design that we've taken to our what's called our Midnight aircraft, which is our production aircraft. And so that's how it got started. As the company has grown, as we've gotten more into operations, we've got some really fun applications when it comes to kind of starting a whole new airline from scratch. That data and optimization and ML and AI are central. And so we are supporting all these different use cases today.
Those thousands of tests seem so interesting. I love this data science that's applied to design. Was there anything that jumped out, like any design concept that seemed good on paper, but when you did the simulation, they just didn't work for some reason? Or was there some insight out of that simulation process that helped with the eventual production version?
I love that. Yeah. I think a lot of, I can't necessarily speak for a lot of our engineers, but a lot of them were a little bit surprised that we had arrived at a maximum range of our aircraft that was a little bit shorter than what some people, I think, had in their prior. And, when you look at this whole exciting new emerging landscape, some people call it AAM or advanced air mobility. Now, there's a little bit of a bifurcation between urban air mobility. Those are the missions that we're after. These are shorter range missions in and around urban environments. And then there's the more regional air mobility model. These connect kind of cities. So think like LA to San Francisco, LA to Las Vegas, et cetera.
Yeah.
Using, not too dissimilar of types of aircraft, electric aircraft, very exciting. We actually sought the urban mission because what we saw, as I mentioned, virtually every large city is faced with this big problem of congestion today, where it can take a significant amount of time to go an insignificant amount of distance on the ground today. So saving those trips and also, Archer, it's not like an Uber model where it'll pick you up anywhere, right? We will operate on a fixed nodal topology where you will have to go to and from vertiports to get to your final origin and destination. So even when you string the first and last mile, there are so many cities for which congestion is such a salient problem that you can save a very meaningful amount of time between those missions. And so I think some people looked at us and said, why aren't we building an aircraft to go 200 miles? Well, because in our opinion, there's a very big market to be had in and around cities today. A lot of the trips go from 20 to 50 miles and can take an hour, 2 hours on the ground today. So those are the missions that we're going after. Another interesting observation is you have so much more density of those trips. So for every trip that you're doing between San Francisco and Los Angeles, and there are many of those trips, and I think there's a wonderful market to be had in the advanced air mobility market as well, in the regional model. But for every one of those trips, you have orders of magnitude shorter trips on the ground. That provides ability, we believe, to deploy high tempo of operations, achieve high load factors, and achieve very high time savings for time-sensitive travelers. And so a lot of people raised a few eyes, but I hope we were successful in kind of showing the advantages of a 60 to 100 mile range vehicle.
Well, I think this is something that's come out in these first few minutes really clearly, John, is that rather than shoehorning an existing aircraft into this urban landscape like this, you guys are designing with that mission in mind from day one.
Exactly.
And it's really interesting. I mean, rarely do we sort of see solutions get planned out with a market as clearly thought out as that, because there are plenty of us living in very dense urban areas, and every day the paperboy brings more. So I'm interested, John, in what you alluded to it a little bit earlier, that you got some raised eyebrows from engineering with some of the analysis you did. You talk about your relationship with engineering, not just with leadership, as well as with field engineers, and kind of where that collaboration's been impactful.
Yeah, absolutely. So the engineering team, my favorite part of my job is I get to have the great uh, pleasure of collaborating with some of the most world-class engineering teams. This includes our airframe team, our battery team, our motors team. We have something like 19 different engineering groups, all of whom we have collaborated in some sense, and I've just learned every day from them. So we started out with a lot of high iteration with this team, as I mentioned, to kind of size the aircraft. A lot of the engineers want to know the mission profile. What is the distribution of mission lengths? Our battery team cares very deeply about that. So when they size their battery, they can kind of prepare for what operations might look like. We work very closely with a number of teams to kind of optimize. We're starting to work on charge optimization. So that's another interesting problem. When you think about it,
Cool.
not unlike traditional airlines that operate on the ground today, they want to minimize that time that aircraft's at the gate. The same is going to be true with us. And what's going to be really important for us is how we're managing what we're calling vertiport operations, and central to that is going to be how much we're charging, because that's going to be kind of the long pole in the tent on the ground, so to speak. So, with that, the question is, you can think about it as two extremes. You could charge with very high power today, which is great for utilization. You're minimizing the time on the ground, but you're really depleting your batteries, which are really expensive and, very, very important assets for us as well. So there's this kind of Goldilocks problem. What is the right amount of power to allocate to every charge event? So we collaborate with our engineers on that. There's a lot of data interfaces. There's a lot of kind of interesting optimization modules that we're working on. And then with flight testing, this is kind of a hot topic. So we just completed our first piloted flight recently at the end of May. And then my team also manages, thank you. Super excited to see a pilot in the cockpit, and it's just been wonderful to watch the culmination of the hard work of so many teams around the company. So I appreciate that, Mike. And then another hot topic that we're collaborating with engineering is on flight test. And so when you think about it, after a flight test is performed, this could be a flight test that's like a virtual flight test in a lab. It could be a real flight test. It is going to be imperative that we are able to scale up the volume of our flight tests to ensure that we're able to fly more and more, because we're going to have to get credit from the FAA, and it's going to be important that we, really scale up that program. So what we've done is we've managed the data. We've built kind of a homegrown data lakehouse architecture that is amenable to really rapid scale and processing huge amounts of data in near time at low cost. And then we're also building various analytic solutions with all of our engineering teams. We're providing them the ability to see how well their systems or subsystems performed on a flight. We're flagging anomalies. So if something looks kind of amiss, we can give them that's immediately up front when they get to their desktop, and they can kind of see the data in near real time. And then, there's a lot of kind of engineering around that solution as well. So those are three really fun areas of collaboration with engineering.
On the batteries, I've always wondered, do you swap batteries, or is that a problem, or are the batteries embedded in the aircraft and you have to charge it with the batteries in there?
Yeah, the batteries will stay in the aircraft. The reality
Okay.
is they're going to be kind of high. They're very heavy. It's a very non-trivial
Okay.
process to swap them out. We get that question a lot, but no, they'll be charged and cooled, in between missions today.
Okay. So that is a huge part of your team, right? Is to minimize that time, because that's non-productive time, right? While you're charging batteries. Yep.
Exactly. It's charging, it's staffing the operations at vertiports, it's defining a vertiport topology, how you connect the landing infrastructure with the gates that you charge and turn the aircraft. And that's actually an interesting problem in and of itself. So there's a lot of really cool novel problems to be solved in this space around vertiport operations, aircraft design, flight operations, et cetera.
Yeah. Yeah.
Hey, John, I want to go back because there are actually too many interesting problems to think about here. But I want to go back to kind of your analysis that must have been fairly early in the process around trip density distributions
Mhm.
and origins to destinations. It feels like there had to be a lot of creativity and curiosity around what's the existing data and how to interpret it. Can you tell us a bit about that adventure?
Sure. Yeah, happy to. I'll try to keep it brief. If you can't tell, I get very excited about what I do, and that's one of my favorite problems. So, what Archer has done is we have procured a number of different mobility solutions that kind of give us a sense of when and where people are traveling in cities. This, you can think of it as a funnel. It's at the very top of the funnel, right? Now, many of these trips are going to be too short. I think your median or mean trip distance is somewhere on the order of 4 to 7 miles in a given city. Those trips are extremely unlikely to be converted to a mode like, Archer Air, for instance, right? So what we're looking at is we're kind of looking at the trips in that kind of the sweet spot on that right tail, right? Let's call it maybe rough. Let's call it 10 to maybe 100 miles, right? Those are the trips that are kind of in our sweet spot. So we'll discard trips that are too short. We'll discard trips that are too long. We'll even discard trips that don't have any congestion. So that kind of gives you what we like to call our total addressable market. So then the question is, how many of these trips will have a willingness to pay for a service like Archer, right? Someone dropping their kids off at school, someone grocery shopping are probably not going to have a willingness to pay for a service like Archer. So what we have to do is we have to build a number of decision-making framework. We've got a model that will essentially kind of predict the likelihood for every single trip to convert to Archer, given the attributes of Archer, as well as the incumbent modes of transit used. We partnered with another entity. We built and calibrated a mode choice model that we're pretty proud of. We've calibrated with a number of cities. So this kind of gives us a sense of being able to replicate what we see in the data today. So when we add the Archer mode on top of that, that's what kind of gives us some insight of, okay, these are the subset of trips that we think are likely to pay for a service like Archer today. So that's kind of the funnel that we go through. But, you're only going to produce so many aircraft. I mean, one of the other really interesting features in this ecosystem is we are going to have to produce aircraft at rates not seen before in aerospace. So we believe very strongly that we're going to be strongly supply constrained in this environment. So, you might not be able to serve all that demand. That's why dynamic pricing comes into play. What is the right price to charge? And so that's a little bit of how we see that funnel, going from a raw trip to a trip that we think we can convert today. There's a ton of details to unpack within that, but I'll just keep it there for now.
Just kind of up at the front end of that, John, so it sounds like whether it's the automotive industry, there's trip data out there. Or there was something to start with around estimating number of journeys, journey distributions, and lengths.
Mhm.
Yeah, I'm not familiar with that space, but was that problem not as hard as I thought, or is it just as hard, and you were making it sound easy?
It's extremely challenging, frankly, and there's actually been a bit of a paradigm shift in that industry. So there's a lot of ways to procure that data. You can get data that is derived from cell phones. You can get data that's derived from connected vehicles. You can get data that's actually modeled. There are very different ways and very different flavors to analyze that. We've spent a significant amount of time. So many of these decisions that we're talking about influence vehicle design, what cities we want to launch, where we want to build infrastructure, how we're going to price the service, how their back-end algorithms are going to actually serve to operate this as a mode of transportation. So this is really important to us. And so we've gone really deep with, I think, virtually every provider out there. And so it's actually a very non-trivial problem. And I think there's a couple interesting opportunities for disruption, to be honest.
When you were doing the simulation, I think people just listen like, yeah, simulation sounds pretty easy, but I'm suspecting I love facility location. I suspect you had a facility location problem in your simulation to figure out how many of these vertiports you needed in each city, right? If you have 20, it's one thing. If you have 30, it's a different thing. And did you go through that process too? Do the facility locations?
Yes. So it's actually interesting. There's a lot of machine learning involved. There is definitely I'm going to call it a facility location like problem because there's some really, really interesting side constraints. Mike, you asked about noise earlier. Like there's actually noise constraints, and so if we operate at too high a frequency at one point, we might increase the ambient noise level in a city that's beyond what's reasonable, and we think that might could be a very strong risk at being ultimately permitted. So that's a really hard side constraint.
Right. Cool.
There's also a very dynamic routing element to this as well. We are not going to be a traditional airline that has a schedule that's published 1 year in advance. We're going to be almost like an Uber or Lyft-like model. We're going to be kind of near on demand, right? So that's gonna beget a whole series of really interesting questions about how to route these aircraft in near real time. So you got some kind of VRP-like solutions, but it's also there's a lot of salient capacity constraints. Unlike a lot of our friends that work at the major airlines, they more or less see a lot of large airports as kind of uncapacitated. You could park aircraft at apron. For us, if we're operating in dense urban environments and you only have 2 pads, that is a hard constraint. So that's actually really interesting.
Cool.
Even the number of aircraft we can deploy is still unknown when we solve our routing models. So there's a lot of really cool features at a 40,000 foot level. It sounds very similar, but when you really unpack some of the features and some of the differences, it's actually there's some really complicated features that have kept us up for many nights the past 4.5 years.
So it's interesting. John, as I hear you talk about different problems and different teams, I, I I'm interested in how Archer has managed kind of ownership and accountability with your centralized group, providing a lot of support, but ultimately people are making calls and decisions. Can you talk a little bit about kind of how those collaborations work, where you've been successful, where you wish you'd have done something differently?
I love that question, Vijay. Yeah, I think, in my opinion, one of the biggest challenges here, and I could not be more proud of the colleagues that I've partnered with here. It's actually pretty interesting, especially when you double click into our engineering team. You've got a lot of people that have deep domain experience that may have worked at some of the traditional aerospace companies. And then you've got some people, especially more likely to kind of work on our powertrain systems, that have worked at more tech companies. So you've got this very interesting kind of mix of cultures, right? And one thing about aerospace, this is why I'm not working for, I was drawn at a very early stage in my career to problems that airlines solve. Those are some of the most interesting, hard to solve, impactful problems one can solve. But the problem is airlines are well known, frankly, for being very siloed, right? They're being very siloed. They're very kind of risk averse. It's hard to get good work, good solutions kind of deployed. It's possible, but very, very hard. A lot of users in the tech world. So what we had to do is we had to spend a considerable amount of time building trust with a lot of our engineering teams, particularly those coming from kind of the incumbents, right? Because they might not be used to, the way of the lens with which we look at a lot of our problems, right? So a lot of times there might be skepticism, and rightfully so. I get that. When you partner with someone that's coming from an Apple or Tesla that's working on our electric powertrain, they get it. That's kind of what they're used to. That's kind of you can get some quick wins. So a lot of it is just having to build trust and to validate. And that's why my team, I'm a big fan of what some data folks call the embed model. I love to get my folks sitting very deeply, attending the daily stand-ups of these engineering teams, getting to know them personally, asking every single question about, these terms. What's a flaperon? Things like that. Like I want them to really understand the domain. Go in very humbly, learn everything you can, because I think that's the best way to spark innovation. Is you have to really understand the user. You have to build that trust, and once you have that, once you can kind of validate, then I think it just unlocks so much potential. So that journey has taken us a lot longer than probably what I thought coming in. So I wish we kind of would have embedded ourselves deeply earlier on. But I think overall, I'm really proud with the scope that our team has, and that's kind of corroborated by the number of teams that we support at the moment.
Just kind of just as a connection to that, John, is your team distributed geographically in these engineering teams, the company, kind of, and how does embedding kind of how do you do that with these geographical challenges? Never mind
Yeah,
COVID in the middle of it.
Yeah, precisely. Yeah. So, I mean, our company's based in San Jose, and most of our engineering team is there. Although Archer is starting to diversify its locations, we've got some software folks in Sao Paulo. We've got a high-scale manufacturing facility coming online in Covington, Georgia, that went online last year. There are a couple of key acquisitions that we have made of key talent from similar peers in Europe specifically. So we're getting more and more geographic diversified. So a lot of it is we just have to kind of meet our users where they are, whether that's physically, whether that's remotely. I live in Austin. I travel out to our headquarters pretty frequently. But yeah, there's especially, I think, when you're dealing with teams that work on the aircraft or other physical systems, it is imperative that you're there on site as much as possible.
So, John,
Excellent.
I'm going to sort of keep on the same theme because I wanted to ask about sort of the organizational challenges. And you touched on it. It's a company like Archer. It could easily go the way of just engineering and say, I don't need data science, but you guys have done a great job of building trust with the teams. What advice would you give to others who are like in a similar engineering heavy kind of industry where they're trying to sell data science? Like how much time do you spend selling up in the organization to justify your team and get resources? Is there any insights you can give people on sort of how to do that?
That's a fantastic question. I think honestly, it's a little bit of both. You kind of have to necessarily get the buy-in, kind of from above. And so we had that at a very early on stage. I had the great advantage of having strong buy-in from our chief engineer initially. So I think I was like the
Okay.
40th person to join the organization. So I saw very much eye to eye with both our chief engineer, our chief technology officer, as well as our executive. So I kind of had that buy-in incumbent. But a lot of people that might be going to another aerospace aerospace company, they might not have that. So I think you definitely have to sell that vision. But you also have to get it from kind of the ground, the soldiers on the ground as well, right? You have to build that trust. You have to get. I'm a big fan of getting quick wins. That's something that one of the faults that I know I personally have made early on in my career is to shoot too big, right? Have a grand vision, try to execute that, impress your audience. And a lot of times what you have to do is you have to do like the less sexy stuff along the way. You have to kind of show, hey, we can replicate what you do. We can kind of do the obvious thing. That's not as exciting, but that's really important to buy that. So I think it's a little bit of both. You have to kind of come at it from above and below, honestly.
Yeah, that's cool. Yeah, I've tell people that sometimes to young data scientists, like sometimes you have to build a dashboard so that you can do the cool machine learning model.
Exactly. Don't be the data scientist that has that hammer and you're just looking for nails. That's not. You want to build technology organically with the needs of the business in mind first.
Yeah.
With that, so let's kind of continue on that theme, Jon. Tell us what your team looks like, both in terms of size, backgrounds, and particular competencies and skills. I know, as just a little bit more background on that, I know you had a heavy transportation, airline, aerospace background coming into Archer. I'm wondering if those are similar to the kinds of people you hire, or do you have a more diverse kind of lens? Just curious as to who lands up in Jon Petersen's group at Archer.
I love that. So my approach to hiring is perhaps a little unorthodox. I look for people that are exceptionally smart and exceptionally motivated, right? And it's kind of easy to find one of the two, but sometimes it's hard to find both, right? So smart and motivated. Maybe you don't check every single box in a job description. Maybe you don't have, years of deploying, machine learning products at scale. But if you have an obvious passion for, what we're building, you can, there's so many new challenges to solve. It's pretty easy to get excited about this stuff, right? So I'm not looking for people that are looking for a job. I'm looking for people that have an unequivocal reason why they want this job, right? And because if you're smart and you're motivated, you can learn a lot of this technology, honestly. If I can do it, I promise you the majority of the people listening to this podcast can as well. So that's kind of one thing. Now, obviously, there are constraints around that to some extent. So that's kind of the approach that I take. We've got a pretty, very interesting multidisciplinary group of individuals. We're only 11 people today. Now we are growing the team. We're going to be almost 20 by the end of the year. And that's a testament to the team and how well they've delivered for so many stakeholders through the years. Like, I'm really proud of that. I like to keep the team as lean as possible, honestly. So the background of the team is quite diverse, as I mentioned. So we've got about half the team are engineers. And these could be software engineers, data engineers. These might be engineers that are experts in building a scalable data infrastructure. And then we've got half the team that are kind of the data scientists, right? So these people could be experts in combinatorial optimization, in machine learning, and increasingly now AI, right? So we hire kind of all of the above. But one thing that stood out is everyone that came to Archer and presented a case study, it really impressed us. It showed creativity. It showed that they are willing to build, as I mentioned previously, they are willing to propose technology with the user and the stakeholder in mind, and not necessarily just the technology. And people willing to kind of think, I hate this cliche, but outside of the box, right? I mean, so airline problems are very fun, and they're very well known. They've been studied for something like 4 decades now. But we're an aviation service provider, but we've got so many novel challenges to our aircraft and our operation. So I'm really looking for people that can kind of see that as well. So it's a very broad, very diverse team. We like to do a lot of quick prototypes. We collaborate very closely with our engineers to make these prototypes live, to get them in stakeholders' hands, get early feedback, frequently iterate, and then kind of seek other things. So that's a little bit about the team. I cannot speak highly enough of my team. I'm just so proud of their ingenuity and their hustle, their intelligence and passion. It's just it's a wonderful group.
You mentioned you briefly touched on the fact that you have to build these vehicles to scale, at a scale never seen before. Is part of your team going to start to sort of focus on that? Like, how do you get the manufacturing facility? How do you find bottlenecks there? And how do you really get that facility scaled up?
Yeah, great question, Mike. That's kind of one of the future directions that we're going to really be increasingly moving towards. So one thing it came down to is the facility layout itself. We've got a very aggressive throughput target of our high-scale manufacturing plant. And so we spend a considerable amount of effort partnering deeply with our team. And by the way, one of the things that I love about Archer is we rely heavily on partnerships. And so we partner closely with United Airlines, for instance, on the aviation side. On the manufacturing side, we've got a great partner in Stellantis, who's one of the largest vehicle vehicle manufacturers in the world. And so we partnered with both internal folks here at Archer as well as some of the experts from Stellantis. We've run simulations to validate our throughput targets on the shop floor to make sure they're robust to the many sources of uncertainty from a supply chain and manufacturing. So we're pretty confident. That's kind of the first step. What we're moving at right now is trying to build an application to kind of optimize decisions made on the manufacturing shop floor. So given the state of our supply chain inventory, we try to optimize kind of the joint decisions of capital and labor to maximize throughput given the state of the world. That's actually very exciting as well. And there's a ton of forecasting in ML, and we're starting out with the dashboards, and we're just trying to get all our manufacturing teams a single source of truth and ability to kind of view the very complex sources of data.
Excellent. I know we're coming towards the end of our time, Jon, but I can't help but ask this particular question. It comes up a lot in the context of central versus decentralized groups. Um, Talk to me to the extent that you can about what your process is like for funding your team from quarter to quarter. Do you spend a lot of time singing for your supper? Do you spend a lot of time kind of getting into the budget mess with peers and sort of earmarking? Kind of what does that look like?
Yeah, it's a great question. I'm a big fan of getting quick wins, right? And so I try to keep my team as lean as possible. I try to make sure that we deliver excellence to our stakeholders. I try to keep my team focused. By the way, one of the challenges of our team is we get pulled in so many directions, right? So
Yeah,
we just don't have the
we can hear
bandwidth.
that big time.
Exactly. That's another source that keeps me up at night a lot. So it's my job to really identify the strategic areas, the priorities. I make sure to deploy our team to execute on those with very high probability, because that's the best way to get future funding in the future. I had 10 individuals come into this year. We're going to be almost doubling, and that's a testament to getting all these wins previously. So a lot of it is, I think you just have to you have to earn your supper, certainly, and then be a great collaborator with the many stakeholders that we have. Honestly, a lot of the mission of my team is also to innovate, which is what I love. I love partnering with our engineering teams who are focused on the execution. It is our responsibility to think, 6, 12, 18 months ahead as well, and to get those teams excited about kind of the future direction as well. So that's another thing is to have an eye in the future, and a well-defined plan to bring innovation to operations and the company at large.
It sounds like what reading between the lines, Jon, it sounds like the quick wins have sort of gotten you both permission and support from your partners.
Exactly. Yep. Actions speak louder than words, certainly. Talk is cheap, and I'd like to be quiet, deliver quick wins, and let the chips fall where they may.
I think that's probably a great point to wrap up. And we could ask another 100 questions. Thanks for your energy, Jon. Any last words on any books people should read, articles, podcasts that you like that you'd like to pass on?
Oh, that's a great question. So in my early on in my career, I wanted to be an economist. I was fascinated with like puzzles that economics brings, like why are countries rich, why are countries poor. So I to this day I jettisoned that career path, but I just personally, might be a little bit tangential to some of the listeners, but I love behavioral economics. It's just fascinating to me. So I'm a huge fan of like Richard Thaler. He wrote this book called Misbehaving. I love books like that. Obviously, Daniel Kahneman, Thinking Fast and Slow, is one of my all-time favorites. Anything in behavioral economics, and there's actually a really interesting bridge, I think, between behavioral economics and decisions, because humans are integral in making decisions. And so, Richard Thaler and Daniel Kahneman are my two favorite authors, probably. So
Very cool.
Excellent. Jon, it's been great to have you on, and really kind of I come away from this conversation saying, when can we get this damn thing to market in the Bay Area? I can't wait to start riding, and I feel all the better because there's so much strong data science underneath those takeoffs.
I love that, Vijay. I love that question. Well, if I don't know if you your listeners heard, but one data point I'll feed you is Archer was actually very recently announced to be the exclusive provider of the LA28 Olympics, and so this is something that we're laser focused on right now. So we'll be certainly bringing our service to market for LA28, hopefully before then, but we'll see. We've got a very long and very rigorous path to get our vehicle type certified. We are actually working also on bringing our market to service in places like the UAE, where we're working closely with Abu Dhabi, with various entities around there. There's a lot of excitement. There's so much energy. I think that's where you're going to see us kind of launching our market, in the pretty near future, actually, before bringing it to the U.S. And so stay tuned, Vijay. We would certainly welcome you aboard an Archer flight, and Mike as well.
All right.
Yeah, last word I'd like to share with our audience is living in the middle of software country, as I have for the last 30 plus years. We talk about innovation all the time, but this conversation has really kind of upped my whole sense of innovation and big challenges and quote unquote changing the world stuff. So, John, it's been a great pleasure.
Yep. Thanks,
It's
John.
been so much fun to join you both. Thank you so much for your time. I love the podcast. Keep up the good work.
All right. Thank
And
you.
finally, everybody, if you like the podcast as well, be sure to like, share, and send us some ideas and suggestions and feedback. You can like and share wherever you get your podcasts. You can send us feedback at decisionintelligencepodcast@gmail.com. Thanks for joining us, and we'll have another episode out in a couple of weeks.